Welcome to This Explainer. Today, we're diving straight into the incredible, expanding story of how our everyday energy use impacts the Earth. We're going to take a really fascinating journey together, starting from the explosive, microscopic chemistry inside a tiny engine block and zooming all the way out to the delicate balance of the stratosphere. It's a story of human ingenuity, some pretty massive unintended consequences, and how the invisible gases we generate shape the very world we live in. Just think about the sheer scale of our footprint for a second. An average car produces a staggering 12,000 pounds of carbon dioxide every single year. To put that into perspective, that is literally 4 times the weight of the car itself. This happens because an average vehicle burns roughly 600 gallons of gasoline a year, and every single gallon releases about 20 pounds of CO2 right into the atmosphere. It perfectly highlights how our daily, seemingly small actions compound into massive environmental impacts. To make sense of all this, here's our roadmap for today. We'll be hitting 1. The price of power. 2. Meet the air pollutants. 3. Tech that cleans air. 4. Smog and acid rain. 5. The greenhouse effect. And 6. The ozone layer hole.
All right, jumping right into section 1, the price of power.
Let's start with the basic conversion of fossil fuels into those modern amenities we've all been enjoying since the 1700s. Whenever we unlock the chemical energy inside coal, oil, or natural gas to get the thermal or mechanical energy we need to power our lives, the environment pays a heavy, very visible toll. The combustion process inevitably releases various pollutants directly into the air we breathe, which, as we know, contributes heavily to health issues and environmental degradation. Moving on to section 2, meet the air pollutants. So, what exactly is spewing out of these industrial facilities and our tailpipes? Well, meet what we call the Big 5 air pollutants. Now, some of these, like sulfur dioxide, are inevitably produced simply because the fuel itself, like coal, contains sulfur. You burn the fuel, the sulfur reacts with oxygen, and boom, SO2 is born. But others, like nitrogen oxides, are actually generated by the sheer mechanics of the combustion process itself, where super high temperatures cause the normally stable nitrogen in the air to break down and react with oxygen. Now, the absolutely crucial thing to understand here is how a lot of these other harmful pollutants are born. It comes down to incomplete combustion. Even if an engine has enough oxygen, the fuel and air might not mix perfectly in the split second they're together. And because oxygen actually prefers to combine with hydrogen rather than carbon, the hydrogen burns completely into water, but the carbon gets left behind. That creates unburned hydrocarbons, poisonous carbon monoxide, or just plain black carbon set. Which brings us to section 3. Tech that cleans air. The good news? Humans are incredibly inventive. Just take a look at this humble-looking device. It's a catalytic converter. Following the 1970 Clean Air Act in the US, regulations got a lot tougher, and these devices were broadly introduced into vehicle exhaust systems everywhere. Their primary job is to actively reduce those unburned hydrocarbons, nitrogen oxides, and carbon monoxide before they can ever escape your car. And it gets really cool if you cut that metal shell open. Inside, you'll find this porous ceramic honeycomb structure. This honeycomb is coated in precious catalyst metals like platinum, rhodium, and palladium. As the hot, toxic exhaust gases are forced through these tiny coated passages, a chemical reaction triggers. It literally forces the harmful pollutants to convert into harmless water vapor, carbon dioxide, and nitrogen right inside the tailpipe. Beyond just cleaning up the exhaust, another massive way we reduce emissions is simply by swapping out the fuel we burn. Switching our power plants from high-carbon coal over to natural gas drastically reduces our emissions footprint. Natural gas emits about 40% less carbon dioxide than coal to produce the exact same amount of thermal energy. That's a huge drop, which is why it's frequently marketed as a clean fuel, though, just to be clear, it is still very much a fossil fuel. It all comes down to pure chemistry. Burning methane, which is natural gas, produces 2.75 kilograms of CO2 per kilogram of fuel. As you can see, that is significantly less than the 3.09 kilograms produced by the gasoline in our cars, or a hefty 3.67 kilograms produced by the carbon base of coal. Let's zoom out a bit for section 4, smog and acid rain. Okay, so we know what's leaving the pipe, but what happens when those pollutants actually hit the open air? If you've ever looked at that dark yellowish-brown haze hanging over a sprawling city on a hot summer day, you've probably wondered, what exactly is happening chemically to make that smog? Well, it's definitely not just smoke hovering there. It's actually an active, ongoing photochemical reaction. When unburned hydrocarbons and nitrogen oxides from heavy traffic just sit in stagnant air, they react directly with the intense energy of sunlight to literally cook up a toxic layer of ground-level ozone. And this ozone is nasty stuff. It damages lung tissue, irritates your eyes, and even harms local vegetation. And it gets worse. When sulfur dioxide and nitrogen oxides from our daily commutes and power plants drift up and mix with water vapor high in the atmosphere, they transform. In the presence of sunlight, they become sulfuric and nitric acids. They dissolve right into cloud droplets and rain back down on us, wreaking havoc on regional forests, spiking the acidity of our lakes, and even eating away at solid marble buildings. Zooming out even further now, Section 5, the greenhouse effect. So, looking at the Earth's entire atmosphere, we run into a totally different issue. You know how the glass windows of your car let sunlight in, but then trap the heat inside on a sunny day? Well, the Earth has a natural version of this called the greenhouse effect. Gases like carbon dioxide and water vapor act like a giant blanket. They let solar radiation pass through, but block the outgoing infrared heat from escaping into deep space. Now, this natural process keeps our planet warm enough to sustain life, which is great, but when human activity causes these gases to accumulate way too fast, it threatens to dangerously alter our global climate. Now, while carbon dioxide usually gets all the attention because we emit so much of it, it's really vital to note that other trace gases are incredibly potent. Compared to a single molecule of CO2, a molecule of methane has up to 36 times the potential to trap heat. And nitrous oxide, which often comes from agricultural fertilizers, is up to 298 times more powerful at trapping heat. That's wild, right? And finally, the highest layer of our story. Section 6, the ozone layer hole. Up here in the stratosphere, roughly 10 to 40 kilometers above the Earth, we faced a massive, massive crisis in the 1980s. We discovered that human-made CFCs, which were chemicals heavily used in refrigerants, were drifting up and literally shredding the protective ozone molecules that shield the Earth from the sun's lethal UV rays. The intense UV radiation actually breaks the CFCs apart, releasing free chlorine atoms. And a single chlorine atom acts like a wrecking ball. It destroys an ozone molecule, gets released, and then just moves on to destroy another one in this devastating, continuous cycle. But hey, here is the genuinely uplifting takeaway from this entire explainer. We are absolutely not helpless. The international community has proven time and time again that we can recognize these microscopic chemical threats and actually unite to successfully stop global environmental disasters. From the U.S. Clean Air Act fighting smog and acid rain, to the Kyoto Protocol and the Paris Agreement bringing 196 nations together to target greenhouse gases, legislation and binding agreements truly work to course-correct our impact. So we've traveled today from the explosive, microscopic chemistry of an engine block all the way up to the delicate, protective balance of the stratosphere. It just shows how deeply connected our daily routines are to the entire planet's ecosystem. Which leaves us with one really profound question about our own personal impact. Knowing how local combustion scales up to global climate change, what choices will you make today to reduce your everyday energy footprint? Think about it. Thanks for joining me on this explainer, and keep learning.